A lot of people may have encountered measurement of weight in the day-to-day life, during buying vegetables at a store or checking weight on a scale. What most people don't know, is that they are using the load cell for measuring weight.
Earlier, old scales, also called analog scales, were used to measure weights by trying and leveling out the weight on the one side of the scale against the known calibrated weight on the other side. Nowadays, we use methods that measure weight automatically through the use of digital scales.
Let us now understand what is the definition of a load cell. A load cell is a force transducer, intended for weight measurement, that generates an electrical resistance whose magnitude is directly proportional to the force being measured. There are 4 common types of load cells. They are pneumatic, hydraulic, strain gauge, and capacitance. Let us now understand how a pneumatic load cell works. Since it is a pneumatic load cell, we know that it will deal with air pressure. A pneumatic load cell consists of an elastic diaphragm attached to a platform surface where the weight will be placed. An air regulator, as the name implies, will limit the flow of air pressure through the system and a pressure gauge. Thus, when the load is placed on the platform of the pneumatic load cell, the elastic diaphragm deflects. The pneumatic load cell then uses pressurized air or gas to balance out the weight of the object. The air required to balance out the weight will determine how heavy the object weighs. The pressure gauge can convert the air pressure reading into an electrical signal. Next, let's talk about a hydraulic load cell. In the case of pneumatic load cell where compressed regulated air was used, a hydraulic load cell, on the contrary, will use compressed fluids such as oil or water. A typical hydraulic load cell consists of an elastic diaphragm, a piston with a loading platform on top of the diaphragm, the fluid inside the piston, a board and tube pressure gauge. When a load is placed on the loading platform, the piston applies pressure to the liquid contained inside it. The increase in liquid pressure is proportional to the applied force or weight. After calibrating the pressure, you can accurately measure the force or weight applied to the hydraulic load cell. Capacitive load cells are built on the principle of a change in capacitance when a force is applied to the load cell. Capacitance is the ability of a system to store a charge. If a capacitor is built using the classic parallel plate approach, then its ability to store a charge is directly proportional to the area between the 2 plates and inversely proportional to the gap between the plates. The capacitive load cell is made up of 2 flat plates parallel to each other. One of the plates is coupled to the platform. The plates will have a current applied to them, and once the charge is stable, it gets stored between the plates. When a force or load or pressure has been applied, this gap between the plates changes due to the deflection of the housing and results in a disproportionate change in capacitance, making capacitive sensors extremely sensitive. In this video, we will explore the most common and popular style of load cells, that is a strain gauge. A strain gauge load cell is a transducer that produces a change in electrical resistance when under stress or strain. The electrical resistance produced by the strain gauge is proportional to the strain or stress placed on the cell, making it easy to calibrate into an accurate measurement. The electrical resistance from the strain gauge is linear and therefore can be converted into a force and weight if needed. The strain is the amount of deformation of a body due to an applied force. More specifically, the strain is defined as the fractional change in length. Strain can be positive, tensile, or negative, compressive. The metallic strain gauge consists of a very fine wire or, more commonly, metallic foil arranged in a grid pattern on an elastic backing or carrier. When strain is applied to a strain gauge, its dimension changes, thus changing the resistance of the strain gauge. The change in resistance is directly proportional to the subjected strain or force. Refer to the complete derivation of the above equation from my blog given in the description. A strain gauge load cell is made up of 4 strain gauges connected in a Wheatstone bridge configuration. A Wheatstone bridge is an electrical circuit that measures unknown electrical resistance by balancing 2 legs of the bridge circuit. One of the legs contains the unknown component. The Wheatstone bridge circuit provides incredible accurate measurements. The strain gauges in the Wheatstone bridge are bonded onto a beam which deforms when weight is applied,